So in this video, we're going to be making something it's not technically Chams, but it does resemble it. And, well, like I said, it resembles it. At the end of the video, you'll end up having this result here. As you can see, their models themselves are glowing red, and you can only see like the solid red whenever they're visible. So what I see with a lot of people, when they are using some sort of glow or ESP, they will be aiming at the enemy, like kind of like they'll see them come around the corner and they'll set up for it and they'll fire. When in reality, they're on the other side of another wall, for example. So that if you're, for instance, getting overwatched, that would be pretty much a dead giveaway that you're using some sort of walls. And this just really helps out do that. And plus, it makes it a lot easier to see crosshair. For instance, if crosshair is green, solid red background to just aim at, it comes up quite clearly. So, why I didn't discuss this in the last video, but the reason we were going to be switching from DWORD to Unicode, to pointer T, is DWORD, from my understanding, you're pretty much limited to 32-bit games. So, for instance, Counter-Strike, that's 32-bit. Whereas if you went to a game that's 64-bit, you would have to be switching over to something such as pointer T. Now, instead of switching between the two, pointer T, as that supports both 32 and 64-bit. We have that entire range to work with. We don't switch between the two at all. If we were to, let's say, copy one of our functions into, well, something that we're using in the game that just so happens to be 64-bit, for example. But now, we're going to be getting rid of this structure for our offsets entirely, as it was my stupidity to not even consider or even think of doing this. We're going to actually be using a stumper namespace as it was intended. So first thing we can do, we can go ahead and delete that structure. Now, if you watch any beginner C++ tutorials, they generally have you do using namespace std. So you can do cout, blah blah blah, instead of having to do std cout. Well, we're essentially doing that here. So as you can see, it has pretty much a couple in it. So we have our case dumper, then we have netvars and signatures inside of that. So we want to include that. So we're going to do using namespace case dumper FRs. And we're going to do the exact same thing for the signatures. And now, whenever we want to access one of the offsets, instead of doing case dumper signatures local player, we just simply do dw local player, and it comes right up just fine. So now let's go ahead and change out all of our old offsets that we're using in the structure. So we know we're using is diffusing this once, so it's m_b is diffusing. We're only using the health, just I health, yeah, m_I health. We're using team, object man. The entity list. The team. It's just I team as well. I team num. We have another one of our team offsets here. And our glow index. That is not right. There we go. Now we just have our two local players. And just for example, if you do have a large project, what you can do is take whatever you're trying to replace, go to edit, find and replace, and quick replace. We're going to replace that with w local player, replace, and that was the last occurrence. Go ahead and build and make sure we didn't miss anything. Alright, and we're good to go. So what we're going to be doing to alter the color is what is CLR render. So pretty much a structure with 3 bytes in it. So we have our first byte, red, green, and blue. So just like we did our glow struct, we're going to do struct CLR render and byte red, green, blue. And it does have an alpha, but from my experience, changing the alpha value literally does nothing. So there's not really a whole much of a point to it. Go down here. Go ahead and actually minimize our set enemy team glow function. So just for testing purposes, let's go ahead and make everyone glow green. So it's CLR render, the name of our structure. CLR render. Go ahead and set that red, green, right. Set that equal to 255. Let's go ahead and write to it. Mem class dot write mem CLR render, the name of our structure, and then the address is the entity plus m underscore CLR render, which should be 0x70. Yes. What I miss? And 5. But am I not using it? Oh, duh. Never actually sent a value in CLR render. Okay, let's go ahead and run it. And when I enable it, see, they now have a, well, he now has a green tint. Although that's quite difficult to actually see the difference, I'm going to just switch that to whatever green and blue makes. I think that's cyan. Alright, red should be easy to see. Sorry for continuing to do this. Alright, there. Now that's, you can clearly see the difference there. So, oh, and random note, to set the values to off, so as if there is nothing, you would need to set the red, green, and blue to -1. So that's if you want it to be completely like normal, if you never alter the color. Because when you do this, you only really need to change the color of the entity once. I believe it's pretty much when they die, it resets, but I'm not entirely sure on that. As for example, I've killed this guy several times and he retained his color, whereas... Wait. No, it's when he comes out of... Sorry. It's when he comes out of, when he's no longer dormant. So, like, if you can no longer see his glow, then, well, his color has been reset. And when he comes back in, pretty much have to set it again if you want to be able to see it. Alrighty, so what we can do now, that's working, go ahead and brighten it up, because I can probably tell that looked nothing like what was in the GAZO. So we'll just leave it. Alright, so we're going to do something to set our brightness. So we're going to make another function, void set brightness. Actually going to move of our handle glow function. It doesn't need it. Why did I go back to that? Alright. So we're going to be using the model ambient minimum offset. So what we need to do, first off, define our value. Now, for me personally, I use 5, but sticking between 5 and 10, it'll generally give you, in my opinion, the most pleasing result. As when you start to go above that, it starts getting too bright, because you gotta remember your character's hands, weapon, knife, and everything glows along with it. And it's not a very good sight to look at. So float brightness, we're just gonna set it to 5. Now we need to create a pointer to it, which is, so it's the engine plus the model ambient minimum offset minus 2C. I do not think we have the up right now, so if we do not, we're going to add it. So you pointer T. We're going to do, call it engine module. We're going to go ahead and get it here. Change this to engine.dll module. Now have our engine.dll to go off of. So int first being pointer, set that equal class.m int the engine plus the model ambient set. So val.engine module plus I search for model ambient min. So that'll give us there. Now we need to do our bitwise comparison. So we set our brightness value. We do our bitwise comparison, and then the pointer we just created, which is Pt.3. So we are going to be reading this differently here than normal. So we already know we're doing an XOR comparison. So int or pointer asterisk parenthesis int asterisk reference our brightness, and do our XOR comparison operator pointer, well, to the one we recently just read in. So now we can go ahead and set it. So class.writeMem integer, and just like before, val.engine module plus model ambient offset and XOR pointer. So now that that's set up, we do need a way to set it to run. So if remember, I last ended off on just using normal key state, and I want it to pretty much, I only want it to run once. So I'm going to do right up here, I'm going to call set brightness. So let's go ahead and build that. The reason I'm doing this is, well, you'll see here in a second, you only really need to call it once. That's done, you can go ahead and, rounds can go by and it's still going to be the same. Let's go ahead and run it. And as you can see, it's already set up and we're quite bright. So when we enable color again, got some red to them. So that's not quite how we want it initially. Our render dot blue 0 our render dot green. As you can see, well, of course, now that I did the brightness, it doesn't want to do it again. There we go. So you can see he is now glowing bright red. Go here, you can see the enemies. They're also glowing bright red, and as they come behind a wall, that color does not show through. As you can see, we're getting a nice bright red glow that can really help us distinguish whether or not they're actually visible or not. So as you can see, I use a small green crosshair. Sometimes that can be hard to see in bright areas, but once it comes behind, well, an enemy gets behind it, nice and easy to see. That's really all. So if we wanted to take this a little step farther, where we write our CLR render, well, we can make 2 of these. Since we already know we pretty much just want it to be solid red for the enemy. Here. Call this CLR enemy. And the same thing again. CLR team. Except we're going to set blue to be 255. Alright, I guess I have to do this in a function then. So we're gonna, since we already know, we're gonna call set brightness. Just to be lazy, we can go ahead and set it in here. Same thing for team and the enemy. Now, CLR. We're going to be writing red to only the. We're going to do that in our else statement where we set our enemy glow. And we're going to be doing the exact same thing. Well, if they're on our team, so CLR team. So when we control F5, alright, these guys are still glowing bright red. Go over to our teammate. Oh, that's me turning it off and on. See, he's blue. Go ahead and see if we can get it run again without screwing up. There we go. You can see he's glowing nice, bright, and blue. So that's kind of our way to have our own little set of shams without actually going through SDK and doing it internally. Now as for setting the brightness, it's a good idea to have it set so you can pretty much adjust it. Raise it or lower it by simply setting it to 0. Like for instance, as you saw, every time I closed it down, well, when I want to use it a lot of the times, some issues would occur. Here, well, when I did it again, because I just opened it up, it, for whatever reason, pretty much disables it. But if I were to go again, as you can see, it's just fine. And it's going to continue to do this no matter what. So what you could do is whenever, let's say you know you're going to close the cheat down, or, well, just close the cheat down, figure out some way to set brightness back down to 0. Then when you write to it again, oh, you open the cheat back up, you know it's going to work properly. You know you don't have to open, close the cheat to get the same result here. And if I restart the round, that's not it. Start game. Even though the cheat is no longer on, you can see the brightness is still there along with the color. But these guys over here are not.
Let's go, everyone.
They shouldn't be. Should have had a space to where they're not being dormant for me. So that means their color should be set. And as you can see, they are not of any specific color. They're just glowing brighter. Since
Report in.
the only thing we're altering currently, the brightness. That pretty much concludes our glow tutorial. So very simple for our jams, glow, everything. About as simple as you can make it, and it's very functional. So to reiterate what we did for our quote-unquote jams, we called our handle glow function. Went down here to, so if the enemy was on our team, all we would do was write a structure that held 3 bytes. We just wrote it to our color, which was blue. So what I mean by just 3 bytes, so for example, how we would write on our very first glow tutorial, when we were writing to glow, we started at our pretty much our base, and we added 0x4, so 4 bytes off of the base, which got us to red. Well, in this case, all these are single bytes, so red being the very, very first slot, such as the base for this one, is 0. So if we wanted to get to green, we would just add 1 byte. If we wanted to get to blue, we would just add another byte. So this is only taking up 3 bytes here when we write to it. And then if they're on the enemy, we do the exact same thing, but for the color red, which we have for our enemy. That would not bring us the result necessarily we wanted, as it would just be a very, very dark color. In my opinion, that's worse than normal without any of the color changes. So we have to increase our brightness. So we do that by reading in from the engine and our model ambient offset. Then we do an XOR comparison. Well, we use the XOR comparison operator, which set our brightness up. Write memory from the engine plus the model ambient offset to what we just created. Well, what we just set. So that concludes our glow tutorial.